Okay, so it's time to get busy with our particle engine. What we're going to do is create both the emitter class and the particle class in this video, starting with our emitter class. See, these two guys are so closely tied together.
Yep.
And because of that, it's obviously pretty important that for one to compile right, we need the other one available.
We do.
So we're going to do both at the same time. Now, we're going to start out with our SDL demo. Joel, go ahead and run it.
All right.
Just as a reminder.
And we'll compile
so here we go. And up it comes. Look at that. Run away. And then our little list box and stuff like that.
Yep.
So at the end of this video, we're not going to see anything different in here.
Right.
This is going to look the same. In the next video, we're going to put it all together.
Yep, we are.
So that you guys have an idea of what we're going to do, let's go ahead and close the application.
All right. And let's create our files.
Yeah, let's start out with making some files.
So let's create our two header files first. We'll create our emitter.h and we'll create our particle.h. Because remember we have particles and emitters.
That's right, two different classes.
And we'll create our two CPP files. So our emitter and our particle. Particle, thank you. And we'll start with our emitter. So the first thing we're going to do is, of course, our if not defined emitter underscore h.
Right.
And then do our define emitter underscore h. And if. And let's go ahead and define our class emitter. All right. And let me go ahead and do the same thing for our particle class, just real quick. And particle underscore h and particle underscore h, and we're going to call this class particle.
And I'm willing to bet you right off the bat that we're going to be doing all sorts of OpenGL stuff from inside the particle, so we can go ahead and include our engine right now.
Sure, let's include particle,
you can do
GL engine.h, there we go.
Yeah, that's just going to be a given.
Yeah. So, let's start out with our emitter class here. So let's start out with our public section. Yeah. And then we're going to define our constructor, so our emitter. And we're going to have an update, which remember is going to be called inside of our SDL demo, and it's going to call the update for every single emitter. So we have our void update, and we're going to pass it long time, so we can get the current time. And that's going to be very, very important to maintain that, to make our particles follow the right timing.
That's right.
And then inside of here, we're going to have a set texture call. And it's going to pass
because as I mentioned in the last video, every single particle that's emitted from this emitter that ends up getting instanced from the class
has one texture. Exactly. And then let's create a private section called add particle. Or actually, let's make this protected, my bad. Called add particle.
Okay.
And we're simply pass it void. And this is the function that's going to be used to add particles. And that's going to be called by update.
Okay.
All right, so let's start defining our member variables. And I'm going to make this public just because our sliders and everything is going to want to access all of these attributes so that we can modify them.
Exactly.
And that's kind of important. So we're going to just make all of these a global. So first, our list of particles. So particle. And while we're here, we need particles. So let's include particle.h. And remember, because we're doing it with emitters, our SDL demo is only going to have to worry about emitters. We include our emitter.h, create an emitter, and that emits particles.
That's right.
So inside of here, what we're going to do is create our texture pointer so that our set texture will actually set the correct texture. And let's define an area called attributes. And we'll just define it like so. And then in here, as we saw in the last slide, there's a lot of attributes we need to define. Our emission rate. This is kind of just going to be a typing thing because we explained all of these in the previous lesson. And we have our life range, size and size range.
Right. Saturation and alpha.
Thank you.
Spread. Gravity. You can do it.
I know.
Position.
And these are going to be vector 3s.
That's right, and rotation.
Remember, we defined the vector 3 class, so we're going to bring that in just a second here.
Okay.
So that we can actually start utilizing the vector class that we created way back in the math videos. So we're going to have our position and our wind. And finally, our rotations. Let me just copy and paste this. Rotation. There we go. Let me go ahead and bring in our header file for that. Let me just add an existing item. I do remember exactly where I put this, right here. So our vector3.h. And we'll just copy that and put it into our directory here. So this is going to be under our, let's see where I put it. Our emitter demo. Getting a little hung up there. So our vector3.h. So here we are. And let's go ahead and...
Instead of including it there, how about we include it over in particle.h because we're going to need it over there, and we are including particle.h here.
Sure, that's fine.
Yeah.
So we can come over here, include vector3.h, and there you have it.
Okay. Just makes it accessible everywhere.
Definitely. So with that, let me go ahead and make sure this renders?
It compiles nicely. And it does.
And it does. Everything is good. So let's go ahead and actually let me go to the SDL demo. Kind of jumping around just a little bit, but that's okay. We're going to include our emitter.h, and we'll be using this inside of the SDL demo.
Now let's go ahead and jump over to our particle.h real quick. And
just kind of start defining the necessities for our particle header file. And basically what we have here is the same things that we talked about in our previous lesson. Basically we need to define, an update, just like we did in our emitter. We need to do the constructor and then a whole bunch of attributes.
Right.
So if we come back down to here, we're going to define our public section in which we have our constructor. And we're simply going to pass in an ID, which is going to be the index into the emitter's list, if you will. Right. And then we have our update function call that's passing our long time, because again, particle also needs to know the current time. And then let's create another public section that's going to define all the attributes for our vector, for our particle. So it's color, same thing we saw in the last lesson.
So position, velocity, acceleration, rotation.
And then our ID. I actually like ID being near the top. So
it makes a lot of sense.
Yeah.
There we go.
Okay,
so after rotation, now we got total life, so float, and life, and then alpha, and size. Okay, now we got bounciness. And then we got a bool. Is it active or not?
And then that's all we pretty much need for now.
All right, scroll back down real quick.
Yeah.
You got two terminators.
Oh, yeah, thank you. It's going to work, but it's not good practice.
That's right.
Let's go ahead and compile this. Thank you for catching that.
No problem. So we'll just do baby steps here and make sure it compiles as we go.
Right. I mean, we don't want to type everything
9,000 errors.
And get 9,000 errors. That would just be bad. So let's include our emitter.h and our include particle.h. And let's go over to, save this out, go to our emitter.h and copy all of these that we need to implement into our emitter.cpp. So erase that out, scope it in.
Yeah.
Everyone should know how to do this.
Block them in.
I mean, they shouldn't know how to do this necessarily, but we force them to know how to do this.
Yes, we do, after doing it 10,622 times.
Yeah, no kidding. So, our emitter constructor, if we go up to here, what does this need to initialize? Well, a lot of things, in fact, because if we come over to our header real quick, you'll notice we have all of these things to do. Texture needs to be set to null.
That's right.
So let's go ahead and start just initializing all of these. So if I come back into here, well, our vectors don't need to be initialized, because in our vector constructor, we automatically initialize everything to 0, 0, 0, and that's fine for now. So the first thing is texture is equal to null. And then we have, let me just do emission rate. We'll just give it a default value. We kind of played with this beforehand and decided that a value of 30 particles a second seems to work really well. Yeah. Just something that works at first, because probably you'll want to tweak it in the end.
Sure. Now the emission radius of 0 means we're going to be emitting from a point.
And then 2.0f for our life range. Set this to a value of like 0.5.
So basically they're looking at living anywhere from
negative
1.5.
1.5.
Yeah, 1.5 to 2.5 seconds.
Right.
Negative. Where'd that come from?
I don't know. And then size, we'll just give this a value of 5. And then the range will be, let's say, 2. And then our saturation, we'll start that out at 1. So full saturation. And alpha, we'll start that out at half. So it's 50% transparent. And we have our spread, and this is going to just equal 1.0. So it shoots out a little bit. And then finally we have our gravity. And we'll have no gravity to start with.
So they're just going up.
Yep. Nothing's going to be blocking them. All right, in our destructor. Did I forget to define?
Yeah, I don't think you did a...
Oh, let me go ahead and put this in. Don't know what I was thinking. All right.
So basically, we kill off the emitter, we need to get rid of all of its particles.
Right, because we are creating them inside of add particle, so we need to go ahead and define a list iterator that goes through all the particles and deletes all the remaining ones. Remember, if they're not active, we will delete them, but there still may be some left over when the user just exits out of it.
For sure.
So, particles.begin, and IT does not equal particles.end. Am I doing that wrong? Did I? Oh, particles. Thank you. Particles.end. I wonder why it didn't pop up there. And then loop through all of these, and simply delete each one.
Right.
And there we have it. So, inside of our update function, let's go ahead and implement texture real quick, because this is easy.
Texture
equals
we need to change that up.
Yeah, we'll call it text.
Yeah.
There we go.
Nice.
All right, so in our update function, this is really the core where everything about the emitter is going to happen. The first thing is, if we don't have a texture for our emitter, let's just go ahead and exit, because without a texture, it's going to look really bad anyway.
Right.
So simply do if texture equals no, return. And let's now calculate the amount of time that has elapsed since the last update so that we can calculate the emission rate. And to do this, we're going to need the last time. So what we can do is do a static last time, long, equals time. So the first time this function is called with a time variable, it will get updated. Or actually, wait, you know what? I'm going to do this a little bit differently here.
Okay.
If I just go back into emitter, I'm going to make this a local variable.
Okay.
So I'll just call this last time. So if I come back into here, down to here, thank you, I'm going to calculate the number of particles I need to emit since the last update. And of course, this could vary highly depending on computer speed, etc. So this is something very important to do. So the number of emission necessary is going to be the time, let me just put a parentheses here, time minus the last time. So the current time minus the last time divided by 1,000. Let me just put parentheses around that in just 1 second. And since this is a long, let's go ahead and cast this over to a float. So I'm converting this, which is in milliseconds, over to seconds. And then I'm multiplying that by the emission rate. Very, very simple. Simply calculating the number of particles I need to emit.
Right.
And also, since we've just declared our last time, let's go ahead and go to the top here and simply say last time equals -1. Something to initialize it, if you will. And on the first call in our update,
check to see if it's ever been set.
Yeah, if it's been set yet, I mean, we can't have a time of -1. So if last time equals -1, we need to be initialized, so last time equals time.
Cool.
And then when it gets to this call, for the first loop around, it's going to simply generate 0 right here. So that's okay. First we generate no particles, and that works. So we're going to do a loop here that loops through from 0 to I is less than num emission. So we need to do a loop that adds in all of the particles, and we simply add particle, which calls our own local function that's going to create a particle. All right, so if num emission is greater than 0, let's go ahead and update the time. So last time equals time. And this is just to prevent, if this is looping way too fast and on every change it simply gives us 0, we wait and then update the last time. So in here, first thing we need to do is disable lighting, because when we're using our particle simulation here, we're not going to calculate any lighting. So let's go ahead and do a GL disable, GL lighting, and then GL disable, GL depth test. And I think this is the first time we've introduced GL depth test. Mm-hmm. And, well, we talked about it slightly before.
We just mentioned it.
That's
right.
Basically, we're disabling any sort of depth test, so no matter where it's located on the screen, it's going to draw it no matter what. Because we're disabling lighting, and we always want our particles to get drawn no matter what. And if otherwise we'd have to sort our particles from distance to the camera and then draw them accordingly. Otherwise, we'd have really distorted results. So we're just going to disable depth test and draw all of them in any particular order. It saves a lot of time and is very necessary to do. Then we're going to push our matrix. So set our matrix mode first to our GL model view. Thank you. And do a GL push matrix. And then do our translate that sets us to our position. So our position.x, position.y, position.z.
And this is, of course, the position of the emitter.
Right. Hence why we push it, because at the very bottom, let's do a GL pop matrix after everything is finished. And then let's come in here, and let's do another thing real quick, and that's to make sure textures are enabled. So do a GL enable, GL texture 2D. And then do a GL bind texture to whatever texture we're currently using. So GL texture 2D, and pass it texture text ID. And then we need to loop through every single particle and update its attributes and call that particular particle's update. And if it's no longer active, go ahead and delete it out of our list.
Okay.
So we simply need to create a giant loop here. So list. Everything good so far?
Yep, absolutely.
So we have our iterator, and we'll just call this it equals particles.begin. And then it does not equal particles.end. it++. The first thing, let me create a local variable real quick here that just points to our particles. We don't have to do a dereference it every single time. Alright, so we want to set our particles acceleration. And we've made all of these public, so we can simply do it like this. Acceleration, we want to set its y to equal our negative gravity. So basically, our user is going to come in and set its acceleration to equal negative gravity. And then what we're going to do is set our acceleration, and we're going to add that to our wind component. Because basically we have two separate forces that influence the acceleration, gravity and wind. Mm-hmm. And all we need to do is first set our y acceleration to negative gravity, because this is a positive value, and we want it to drop down, which is negative.
Right.
And then our acceleration, we just add that onto whatever acceleration we have. And the particle is going to handle how that all works out. Mm-hmm. And then we're going to do a particle, set our particles alpha equal to alpha, and then our particle's rotation equal to the rotation of the emitter. And some people will do this in the initialization step only. By doing it this way, we allow
real-time feedback while we're adjusting our controls.
Exactly. So what we're going to do here is do a particle update, and we're going to pass it our time. So now we're updating the particle, which is also going to draw the particle. Then we're going to do a simple test. Is the particle we're currently looking at, is his active state set to false? If so, we need to go ahead and delete it. So what we're going to do is we have our particle that we want to delete. So let's do a delete particle. And then this is something interesting. So I'm going to type this out here real quick, and then I'll explain exactly what I'm doing here. PIT negative negative. Basically what I'm doing right here is I'm storing the current location of our iterator and then minusing that PIT. So we go back one, because we're deleting our current item, right? Mm-hmm. So we back up our iterator so it points to the last item, and then we're going to go ahead and erase it from the list so that item doesn't have an empty reference, if you will. Does that make sense?
Yes.
So we're going to do a particles.erase, and then we're going to delete ptemp.
Okay.
So finally, we make sure our GL pop matrix, let's go ahead and do a GL matrix mode, just in case our particle actually modifies which matrix we're modifying. It shouldn't, but just in case.
Just in case. Never hurts.
Never hurts. Now that we have that set up, let's go ahead and do our add particle. And this is the final function, if you will, that's really, really important for our emitter. And this is where everything gets created. Recall that right up here, we loop through all of the number of emissions that we need to have, right, and we call add particle. So if I come all the way down to our add particle here, first thing we need to do is, well, create a particle. So let's do a particle equals new particle, and we'll pass it the size of our list. So particles.size, something like that. Now we need to generate a whole bunch of random numbers to initialize our particle engine. So, for example, we need to generate a random color for our particular particle, right? And so, and this brings up a really important thing. We're going to have to generate a lot of random numbers between 0 and 1 during this process. So let's go ahead and create a really quick utility function that allows us to very easily create a random number between a specific value. So if we come back over into our emitter header file here, let me create another protected file, value function thing called frand.
Okay.
And we'll pass it start and a float end. And what this is going to do is send us back a random number between start and end, and it's a floating point number. So let's copy this, go back into our emitter, add this in. Don't forget to scope it in. And then inside of here, it's very simple. We actually did this in the previous lesson, one of the previous lessons. Generate our random integer number and divide it by the max random number that we can make.
Right.
And that generates a value between 0 and 1. And then all we need to do is return a value, start plus end minus start multiplied by the number that we just calculated. So if I just walk you through this real quick, it's very simple. Calculate the total magnitude between end and start, multiply that by a value between 0 and 1. So we get a value between 0 and the difference between these two. And then we add on the start, so we end up getting a value between start and end. And then we simply return that. So now inside of our random number generator here, in our add particle, it's very simple to generate a random number. If we want to generate a random number between 0 and 1, frand 0, frand 0, 1, and we would be done. However, we want to take into saturation as well. So what we're going to do is do an frand. And actually, let's go back into our emitter.h real quick here. And let's set default values, because by default, we want to generate a value between 0 and 1.
Okay.
And then if we come back into here...
This just keeps you from having to always specify.
Yeah, because we're going to be using random numbers between 0 and 1 frequently. So let's do an frand multiplied by the saturation, and then add that to 1 minus saturation. And that's what basically allows us to have, if saturation is... If I come back up here, you'll notice that saturation is 1 by default. So if I come back into my add particle, right here, if this is 1, then this value right here will be max. And 1 minus 1 is 0, so this component is going to be completely disregarded. So when frand times saturation, this is going to give us completely random color, and saturation is not going to be taken into account. When it's the other way around, saturation is 0, then this random number is taken out of the mix. So then let's do the same thing for our G and B components. So all we need to do is set G and B. And then we set our particle color to equal a vector 3, R, G, and B. And then we want to set our life to something. And this is really easy to do with our frand function. We want to generate a random value between life minus life range and life plus life range.
The variance that we was talking about earlier.
Yeah, exactly. And then let's go ahead and set our total life, because remember, life is what's going to be modified inside the particle class, and total life is just there to store the life value so that we can reference what our total life was. So we simply set total life equal to life.
Right.
And at this point, we need to set the velocity. So let's set the velocity equal to vector 3, and then basically we're emitting with up being up in Y,
right,
and X and Z is where our spread is going to happen. So we need to generate a random number for our spread in X and Z. So let's generate frand between negative spread and positive spread. And this is 1 by default, so it's from negative 1 to 1.
Okay.
And then let's just generate a random velocity here between 3 and 20 for our Y component.
For our Y,
yep.
That's right.
And then finally, we'll generate another frand between negative spread and positive spread.
Okay.
Let's just close that off. So that's our velocity. Now, we still have a few more to go, and then we'll be done with our emitter class. Our acceleration. We'll start this out to equal frand size minus size range, just like we did with our life range, to size plus size range. And then do a random size as well. So size equals frand from size minus size range. Oh, wait.
Hang on. Acceleration needs to be 0, negative gravity.
Let me copy
0.
this and paste this in here, because I was...
One ahead?
One ahead, exactly.
Yeah, if you guys remember, basically with acceleration, what we're going to do is just a vector 3 and a 0, negative gravity, and 0. And remember, by default, what is gravity? It is 0. So.
Right. But remember, again, that we're setting... This is for our default value. Inside of our particle, we are updating the acceleration constantly.
Oh, absolutely.
Anyway.
Absolutely. Well, the moment that the user goes in there and hits that slider, it's very important.
Yeah. And again, if you don't want that kind of immediate customizability, what you could do is simply put whatever is here, down here, and never change that in the loop. And that would essentially increase the speed of your loop significantly.
Sure.
Significantly. So finally, we need to set our random position, because remember, we have an emission radius to take into account as well. So we have our particle position dot x equals frand emission radius and emission radius, between negative emission radius and positive emission radius. And the same for z as well. So let me just copy and paste this. So we have our particle. Now we need to go ahead and throw our new particle into the list. So our particles dot pushback particle.
Nice.
And there we have it. So that is our particle class.
Yeah, emitter class.
Emitter class,
That's
yes.
right.
So at this point, we just need to go ahead and implement our particle class. And after we're done with this lesson, we're going to be putting all of this together into an actual demo. So we may come back in here to our emitter class and particle class and change a few things around to show you how things work, how to optimize it, etc.
Exactly.
We're just kind of blocking everything in here so that we can start putting all the pieces together. So if we come into our particle, or actually our particle.h, and you'll notice we have only two functions to implement. Count them. Less typing for me is always a good thing. So particle, and let me scope this one in as well. So our particle, there we go. And we need to set the ID, so that's which is passed to us. So ID equals ID, so let's go ahead and change this over to ID, capital ID.
That's right.
And let's see, what else do we need? We need to start initializing all our variables as well. So we'll have our total life. Of course, we don't need to worry about this too much, because in our emitter class, we initialize everything. But this is just in case the user may want to go ahead and manually create a particle for some strange reason.
Right.
So our total life is going to equal 0.0f. Our life will just equal 1.0f. Or actually, let me just initialize both of them to 1.
Okay.
And this basically sets the total life to be 1, and then the life drops.
Okay.
So we give our particle a default life of 1 second by default. I know it's cruel, but hey. Alpha will be 1, so full intensity. Size, we'll just give it a 1. And bounciness will simply equal 0.9. So the reflected vector is basically going to equal 0.9 of the original magnitude, if that makes sense.
Yeah, most of it, basically.
And then active, we'll say that it starts out active. And we'll also need a last time for the particle as well. I don't think I put this in here. No, I did not. So what I'm going to do is add in a long last time.
Okay.
And we're going to emit our last time equal to -1. All right. So let me go down to our update function. Now, the update function is kind of long, so brace yourself for quite a bit of code, but not too bad.
No, it's not that bad.
No, it's not that bad. First off, if the particle is already not active, we don't need to do anything. So let's do an active. If that equals false, go ahead and return.
Okay.
And if the last time hasn't been initialized yet, so it's equal to -1.
Let's initialize it to time.
Let's initialize it to time, exactly. And just as a reminder, time is in milliseconds. So we need, if we want to be working in seconds, we need to convert that over.
That's why you're going to see the divide by 1,000.
All the time.
Yep.
So let's do a float change, which is going to be the change in time. And that's simply going to be time minus last time divided by 1,000.
And this gives us the number of seconds since our last update.
Right. And let me go ahead and cast this over to float, just for good measure. So there we go.
Yep. Let's calculate the velocity.
Right. Let's calculate the velocity. And you may all remember from your physics class how this kind of works. We need to add our velocity, acceleration to our velocity. So acceleration multiplied by the change in time that we've currently had. And with this new velocity, let's go ahead and update our position. So position plus equals velocity multiplied by the change in time.
Okay.
And this basically allows us to simulate sort of kind of realistic environments. And finally, with that, let's do a quick calculation to see whether or not we've collided with the floor.
Okay.
Now, this may seem... Yeah, go ahead.
Well, I was just going to say, our floor is really just a position. It's not
right, it's
really
kind of
a floor.
It's an invisible plane. It's a collision with a plane along the XZ axis,
right.
XZ plane. So it's really simple to calculate. All we need to do is say if the position in Y is less than 0.0f, and of course you can come in and optimize this however you want, add in collision with geometry, etc.
Sure.
But typically with a particle engine you want to minimize the amount of calculations you could do, because the main focus is to simulate real world, effects.
Right.
And that requires a lot of particles. So you can't have really intensive calculations inside of here. But anyways, let's go ahead and reverse our velocity by simply doing velocity.y multiplied with a negative bounciness, as we defined before. Mm-hmm. So it's going to invert our vector so it shoots up now. And then we set our position.y equal to 0 so that if it's still less than 0, if it shot way below, it doesn't keep colliding with the ground.
Right.
And with that, let's go ahead and define a few... let's see. The first thing I want to do... Let me define the particle. We basically want to fade in and fade out for each of our particles. Otherwise, they'll just pop into existence and pop right out of existence, and that's never good. So the first thing is we're going to define a constant float time, fade out time, essentially. And we'll set this to 0.2f, so 0.2 seconds. And what we're going to do here is if the total life, remember that's the value that does not change, minus the life is less than fade time. So it's basically just come into existence and it hasn't even lived for 0.2 seconds yet. Let's allow him to fade in.
Right.
So inside of here we'll simply do a GL color for F with a color.x, a color.y, and then we're going to set the transparency in just a second here, and color.z. And total life minus life, remember, that's going to be a value between 0 and 0.2 if it gets inside of this if statement. And we're going to divide that by the fade time. And then multiply that by our alpha. So that if alpha is, say, 0.1, we never reach, say, 1, and then it pops back to a lower alpha.
Right.
So this basically normalizes it, if you will. Otherwise, it could be still less than 1, so we can say if life is less than 1, in other words, it's about to die. In 1 second, the particle is going to die. We're going to go ahead and do a GL color for F with color.x, color.y, and color.z, and we'll simply call this alpha, life times alpha. Because remember, life goes to 0, and by the time it's less than 0, the particle is going to be dead. So this allows us to fade the particle out of its life. In fact, we can even come in here and do a fade out time if you wanted to. So there's a lot of things you can add and remove, or new features for a particle engine. It can be huge. Let's go ahead and put a semicolon here. Otherwise, just set the color to...
Just copy that line.
Oh, okay. Sorry.
All you got to do is just remove life out.
Yeah, there we go.
Nice.
So with that, let's go ahead and translate our... So we've got pretty much all the information we need. We've initialized everything.
We're staying steady. We're fading out.
Now we need to set our position for our particle. So we'll do a simple GL translate F. You've all seen this by now. And we'll simply set it to the position.x and the position.y and the position.z. In fact, to make this a little bit easier, we're kind of going to use position quite a bit here. Mm-hmm. So let me go ahead and come up to here. After we've calculated the new position, I'll create some local variables just to make it a little bit more accessible for me.
Yeah.
Which makes sense.
A little less typing, too.
Yeah, a little less typing. That's really the main thing.
I know.
And position.z.
Very nice.
At this point, it's moved. But what if we want our particle to always be facing the camera? And this is exactly what we want, in fact. And if you go all the way back to our transformation matrices lesson, you'll remember that when we did our rotation matrices, they all modified the 3x3 matrix that was on the top left of our 4x4 matrix.
That's right.
And what we can do is if we set that quadrant, if you will, of our matrix to the identity matrix with ones along the diagonal, we essentially remove all rotation, effectively making the face towards the camera.
That's right.
And so what we're going to do is create a model view to store our temporary matrix. And then what we're going to do is do a GL get float. This is the first time you've seen this, so it's very, very important that you pay close attention. And what we're going to do is get our model view matrix and pass it our model view. So this line right here is going to actually physically retrieve the model view matrix off of OpenGL and store it into our model view matrix array, if you will. And then what we need to do is loop through the top 3x3 matrix and set it to the identity matrix.
Mm-hmm.
So what we're going to do is do an int I equals 0, I is less than 3, I plus plus, and yeah, that's good. And do a for int j equals 0, j is less than 3, j plus plus. So if we're on a diagonal, and to calculate whether or not we're identical, a diagonal, all we need to do is set if I is equal to j.
Yeah, just think about it. 0, 0, 2, 2,
1,
3,
1.
3, 1, 1. Exactly.
Then we just set our model view matrix at I times 4 plus j equal to 1.0. And all this I times 4 times j is doing is calculating where inside of their matrix it is. Because our 16 array matrix is linear, right?
Mm-hmm.
And our 4x4 matrix usually has rows and columns, and right here we have I and j. So we need to calculate the index into this array.
Exactly.
And that's simply done with I times 4 plus j, because remember, it's a 4x4 matrix.
Right.
Otherwise, we simply set, the model view equal to 0.0. So that essentially erases and converts the 3x3 in the top left of our 4x4 matrix into the identity matrix.
Exactly.
So with that, we should have it working, but we need to get this model view matrix that we've modified
into
back
the real model view matrix.
So what we're going to do is do a GL load matrix F and pass it our model view matrix.
And of course, since it's the model view that's been set, that's what receives this custom matrix of ours.
So at this point, let's go ahead and draw the particle. And this is really easy to do. We can come in and do a GL begin. And we'll use triangle strips in this case.
And of course, we do have textures enabled, so we do need to make sure that we set the S and T coordinate
right,
as well.
But we are not using lighting, hence we don't need to calculate normals.
That's right.
Which is nice. So inside of here, we're going to have a GL text chord 2F. We're going to start at 1, 1. And then let's create our vertex, 3F. And remember, we want our particle, if you will, to be a certain size. And we have that stored in the size variable. So we can do a size, comma size. So that's going to be the size of our particle. And the last component is simply going to be 0. Let's just copy this 4 times. And our coordinates are going to be 1, 0, 1, 0, 1, 1, 0, and then 0, 0. And for here, we have our negative size, size, negative size, and negative size, negative size. Negative size, negative size. There we have. So we've drawn our particle. Now at this point, everything is pretty much done, but we need to start decreasing the life of our particle. And this is, of course, very easy. Remember at the very top here, if I just move up, we calculated the amount of change since the last time we came into this loop. Subtract that off of life and we're done. So life minus equal change.
As we work our way towards 0.
Yep. And then if life is less than or equal to 0.0f, it needs to die. So set the activity to false. So active equals false. And then we'll simply set last time equal to the current time. And finally, we need to restore our matrix. And now this becomes very, 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 very important because we've just totally mucked with the matrix here. And if we don't pop the matrix back, it's going to not be too happy.
No, not at all. We did push up at the top, didn't we? So much code.
Oh, we did not. It's a good thing you reminded me to do that, because if we didn't push the matrix at the very top here, we would have been in trouble. So we simply do a GL matrix mode and GL model view.
And then just simply a GL push matrix.
GL push matrix.
There we go. Now we're in good shape.
Yep. All right, let me put this at the very top, because I typically like to do it right before anything else. So right here.
Okay.
If you don't mind.
No, not at all.
So let me see how many errors I got. So hoping I didn't have any errors. So for a list, particle, list, iterator is not a global namespace. Okay. If we come back into our emitter here, we're utilizing list, but we're not actually using list. So we need to include our list and do a using std list. Oh, man, that killed almost all of our problems. Oh, and I suddenly threw a PIT instead of an IT. Don't know what I was thinking, though. Wow, that's not too bad.
Wow. No, not at all.
So basically, that's our particle engine. There are a few things that I'm going to add in the next lesson as we see things. And basically, I want to be able to
show it to you guys what it's going to do when you add it.
Right. Yeah. Basically, this is the framework, if you will. And once we have it working inside of our SDL demo, we can add things, and you'll see exactly what's happening. Because a particle engine is one of those things you have to see to really understand.
Exactly. Cool. So with that is going to wrap up this video. Thanks a lot.